Hello and welcome to Saturday's edition of Cracking the Cryptic, where we've got a very colourful looking puzzle for you today called Rings and Cages number 3 by Steve360. So I think this is a debut on the channel for Steve360. And Steve360, you may not know this, but I do. This puzzle has actually been recommended to us by none other than Christoph Seeliger, who has been admiring your puzzles greatly recently. He's very, very impressed by the work you're doing, and he suggested this would be a good fit for the channel, so I'm definitely looking forward to trying it. Praise from Christoph is well earned, let me tell you. Now, I've got some things to tell you about today. The first is that, somewhat against my better judgment, I have to say, I am going to be live streaming my attempt to solve this puzzle, which is called Chaos Construction Lighthouse by Phistomefel. This is the puzzle here, tomorrow evening on the channel. So at 9 o'clock tomorrow, I'm going to give this a go. I am extremely nervous about this because this puzzle is apparently an absolute beast. We talked about mind flayers yesterday. Well, apparently this is really something very difficult. The reason I'm starting the stream at 9 rather than the normal 10 o'clock is because this could take, well, it could take me all night to solve it, if indeed I can solve it. And there is a fair chance I won't be able to, in which case, and this is the big advantage, I'll be able to appeal to the hive mind and the viewers to help me. So I hope I won't need your help, but I may do. So if you want to be in the audience for that, I would really, really welcome your company and support. So 9 o'clock tomorrow, I'll try and put a link to that stream on the screen right now. And I can tell you, if you're a patron of the channel over on Patreon, you see there's this puzzle here, which is for illustration. Here is an example of a 6x6 grid. So this puzzle has some rules in it that are quite weird. I read these earlier. And Mark has solved this example puzzle for you guys on Patreon. Now you may think, well, why has he done that? That should be a very simple exercise. Well, he told me it took him 38 minutes or something to solve the example. So the example is meant to be like really simple, but apparently this one isn't. So yeah, do watch that video. It's available right now on Patreon. And of course, I'll try and put a link to that on the screen now. Patreon is worth doing, by the way. It is, well, it is the best Sudoku club in the world. And some 6,000 of you are patrons of the channel over there. And we hope that you enjoy the value you get for that. We do try and make it worthwhile. Now, the only other thing I've got to mention today is, of course, our book, which, here it is. I keep showing you because I'm so proud of it. Many of you have downloaded the PDF, which you can do now. Just log into the Kickstarter where you supported the book on the Kickstarter, and you will find the PDF there. So you can download it and look at it and play the puzzles and find the extra videos, etc. We've had loads and loads of emails saying, I missed the Kickstarter. Can I get the PDF another way? We are working on a website that will let you get it, but it's probably going to be, well, we're hoping to get it up by the end of the month. As and when I have news about that, I will share it with you, of course. But some of you have not only downloaded the book, you have also completed the puzzle hunt in there that we included. So very well done to Jan Gazelius, to George Fotinopoulos, that's a Greek name, and I think George knew I would struggle to say it, so George, that was my best effort, I'm sorry. Evan Wong, Harrison Stein and Julie Smith, all of whom have successfully sent us the correct answer. Now, all that said and done, let's get on with Steve360's puzzle, and I'll read you the rules. We've got the following. We've got normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage. Adjacent digits in... Oh, hang on. I'm just getting a text message and all sorts of things are... hang on a sec. Okay, no, it's fine. It's one of those texts that I think, oh gosh, what's that saying? But it's fine. It's fine. I can carry on reading the rules. So basically we're saying those 3 cells sum to 8 in the first bit of the rules. And then it started saying something weird, which was that adjacent digits in the green ring are never more than 4 apart. never more than 4 apart. So this is like the opposite of German whispers. In German whispers, adjacent digits on a line have to be at least 5 apart. And this is saying that adjacent digits in the green ring are never more than 4 apart. So they have to be sort of close together. So we've got some sort of close together, some neighbourliness going on in the green ring. I approve of neighbourliness. That's very nice to see. This is our quest to make the internet a kinder place, of course. Now, adjacent digits in the blue ring are a multiple/factor of each other. Okay, so when we have 2 digits together in the blue ring, let's imagine that square was a 3 for a moment. If that's a 3, then this square is either a factor of 3, which would only be, could be a 1, or a multiple of 3, which could be a 6, or it could be a 9. Okay, so the blue ring is, there's a mathematical relationship between adjacent digits, as there is in the green ring. It's just a slightly different mathematical relationship. Anyway, do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. I can see immediately a 17 cage in 2 cells. I will fill 8 and 9 as the options for that domino in. Now the secret. I can see the secret, or I know the secret, and that's going to allow me to write this digit in, look. So, someone said I should do more Agad-Mator style things. So, pause the video. If you want to work out how to get this cell and you're not sure, pause the video, and because I'm going to tell you in a second. Now, of course, the way we get this cell is because of the secret. And the secret is then any complete row, complete column, or complete box of a Sudoku contains all of the digits 1 to 9 because of the rules of Sudoku. That is the rules of Sudoku. A row must have all the digits from 1 to 9. Now, if you add up the digits 1 to 9, you get 45. So I know those cells add up to 45. And then we know that these are 24, 39. Yeah, so these cages here add up to 39. So this domino must add up to 6 to ensure that the row adds up to 45. So if you were able to do this, congratulations. The answer is 2. We need to put a 2 here because once we know this domino adds up to 6, 2 plus 6 equals 8, and we get a digit in the grid straight away. And that means this 8 cage must be 1, 5 and 2. That's the only way you can make 8 without repeating a digit, and you can't repeat a digit in a box of a Sudoku. And actually, I think we're going to have some sort of mathsy type thing going right round the perimeter here, because we can carry on with this, can't we? Let's look at column 9. So we know these cells I've just highlighted, they must sum to 45, but we know that these 11 cells sum up to 24, 39, 40, 48. Oh, good grief. Right, so these 2 squares have to add up to 3 in order to ensure these add up to 45. Now, if these 2 squares add up to 3, that definitely can't be a 5. So that's a 1, that's a 2, that's a 5, and we are off to the races here. These 2 squares add up to 7. That's rather annoying, isn't it? So they're either 1, 6 or 3, 4. Don't know if we know which of those is correct. But let's carry on with maths so we can do exactly the same trick. Look along the bottom of the grid. These squares add up to 45, but those 11 cells there add up to 20, 40, 49. Yeah, okay. So again, these 2 squares have to add up to 4. So we can immediately get rid of 4 and 6 from here. Whoopsie, get rid of 4 and 6. So this can only be 1 or 3 now, so that can't be 1 or 3. And that must be a 1 or a 3 as well, to make sure those 2 add up to 4. Now, what next? Well, I think we'll just carry on, shall we? Again, we can carry out the same trick again. These 11 cells add up to something. Haven't done the maths. 33, 43, 54. Right, so if these add up to 54, these 2 squares must add up to 9 to ensure this whole column adds up to 45. Unfortunately, that doesn't seem very helpful. Am I going to good lift these cells? That's the question. Can I actually rule much out from these? I guess in a 12 cage, this can't be a very low digit. So that's got to be at least a 3. 3, 4, 5. It can't be a 6 because you can't double 6 the 12 cage. 7 or 8. 3, 4, 5, 7 or 8. It's not 7 because that would require a 2 to go there. If we know these two add up to 9, you can't go 7, 2. That's going to clash. So we haven't really done very well here, have we? Oh, it's not 5. There's a 5 here already. Now,
I can't connect to your Wi-Fi
what
network.
did I say there that sounded like Alexa?
In the help section of
I
your
didn't
Alexa
say
app.
anything, did I? Constantly baffled by technology. Right, these two add up to 9. So this is a 6, a 5, or a 1. Right, that's definitely not a 5. Look, that's quite an interesting little bit of arithmetic. If this is a 5, how do you fill that domino in? It has to add up to 6. So it's either going to be double 3, because this can only be a 3 or a 1, or this is a 1 and this is a 5, and that repeats the 5 in the box, which also won't work. So actually, that square is not 5, and this is quite restricted now. We can get rid of 4 up there. So, and this is in a 12 gauge, so this square is either 9 or 4. And, oh no. So if that's a 9, this is a 7, 8. That would have to be a 4, 6. 4, 6. The other thing is, the other thing I haven't actually even thought about yet in this puzzle is that it is a bit screaming Phistomefel ring at me, isn't it? Actually, let me just think about that for a second. Is that actually a sensible thought? What was the blue ring? Adjacent digits in the blue ring are factors or multiples of each other. Right, so prime numbers in... Oh no, well, it's not strictly true, is it? Because you can have multiples, digits like 3 are not that restricted in the blue ring, because you could put 3 with 6 or 9. 5 is restricted. Because if you put a 5 on this ring, what do you do with it? You could never put a 5 there. If that was a 5, the only digits that could be adjacent to it would be 1s, and they would repeat the 1s in the row. Because you can't put 10 into a Sudoku cell or some higher multiple of 5, so you've got to put a factor of 5 in, and the only factor of 5 that can go in is going to be a 1. So yeah, and there is a 5 here. Now, wow, okay. Sorry, and some of you may be wondering why I'm looking at this. If you're not familiar with Phistomefel, there is not a theorem, it's a proven truth about Sudoku, which is that this blue ring here, this 16 cells in the blue ring, are the identical digits to these 2x2s, these 16 cells in the corners. So I know this to be true. I will prove it if I can see that it makes a difference to this puzzle. But just take it as read that this is true at the moment. And the reason I think this might be interesting is that if I've got a 5 in the corner, I therefore got to put a 5 in the ring, and we've just worked out a 5 in the ring has to be adjacent to 2 1s. So there must now be a 5 in this puzzle in one of the corner cells of the ring, and it can't go here because there's already a 5 there. So there is a 5 in one of those 3 cells, and it's going to have to be flanked by double 1. Which feels like that is a very interesting thing to have to happen. But having said that, I think this is interesting, but I can't see what it's doing. So maybe we leave Phistomefel alone for a little while. I've got a horrible feeling that this is meant to be telling me something very, very obvious. Well, no, okay, that can be a 5 because that can be double 1, can't it? I think. Yeah, then that would be a 1. And we can have a 1 down here. Okay, sorry. Yes, so this is a digression. Let's get back to it. What else can we do with what we've worked out so far? We can say 3. Oh, I see. Hang on a minute. Hang on a minute. Yes, that's good. Okay, let's look at this digit. So I got this digit a few minutes ago, but didn't really focus on it because I didn't think it was going to be that important. But if that's a 1, this square's a 3 and this square's a 4. But because this is a 1, these two have to add up to 10. So they have to be a 6 and a 4. And you can't put 2 4s in the corner of a Sudoku if they're in the same row. That won't work. So that square's got to be a 3 and this square's got to be a 1, which means this square's a 6. This square's a 1 and this square is a 7 to make the maths of the 11 cage work. Now we knew those two squares had to add up to 9, so this becomes an 8, that becomes a 4. The 6 cage must now be a 1 5 cage because it can't be a 2 4 cage. The 15 cage can't be a 7 8 cage, so that's a 6 9 cage, and the 10 cage must be a 2 8 cage to complete the column. So now we can... Oh, I know what we can do. The 12 cage. In the top row, this 12 cage is not 5 7 or 4 8, so that must be 3 9. So these squares have got to be 2, 6 and 7 to complete the row, and they do add up to 15, which is a good sign. Those squares add up to 9, and they're not 1, 8, 2, 7 or 3, 6, so that's 4, 5. And those squares have got to include an 8 and a 9, so they're 3, 8 and 9 to complete the 20 cage. That's not a 3. 8 9 here means this is a 3, so we're getting actually quite a lot of progress here all of a sudden. This 15 cage is not 6 9, so that's 7 and 8. I can see something that's doing. I'll show you in just a second what that is. 3, 4 and 9 into that 16 cage. Now look at these 8s sort of aligned in row 6 and row 7. Now the facetious question we can ask here, which is an important one, is if we considered row 6 of this puzzle, how many 8s are we anticipating there would be in row 6 of the puzzle if we complete it correctly? It's not a trick question. The answer is 1. How many 8s are we planning for there to be in this row? The answer is 1. So in these two rows, there are going to be 2 8s in the finished puzzle. But I know for a fact that there's an 8 in that domino and an 8 in that domino. So the 2 8s that exist in row 6 and row 7 are in these cells, and therefore not also in this cell. If this cell is an 8, you can see quite simply you'll get a repeated 8 in row 7 because you're forcing 3 8s into 2 rows. Don't do that, you'll get the answer wrong. So that's got to be 9, that's got to be 8, and then we get to say bobbins because the trail runs cold. So, but now I've got to 7 here. So I've got a 7, as well as having a 5 in a 2x2 in a corner, I've got a 7 in a 2x2 in a corner. Now 7 is prime, and I can't include a multiple. So there has to be a 7 in the blue ring because of the Phistomefel theorem. And if you put a 7 in the blue ring, what are you going to put next to it? You can't put a multiple of 7 next to it. So you've got to put a factor of 7, which is 1. That's the only factor that works. So now, not only is there a 5 surrounded by 2 1s in a corner, there is a 7 surrounded by 2 1s in a corner of the Phistomefel ring. So there are 4 1s in the Phistomefel ring. Oh, this is just beautiful, isn't it? this is just I think I'm going to have to prove Phistomefel because the fact there's 4 1s means this square here can't be a 1, because then I couldn't put a 4th 1 in the 2x2s in the corners. There would only be 3, but I know there must be 4 because of the blue line rule. So this square is going to be a 1. So I do need Phistomefel, and if I need Phistomefel, I'm going to prove Phistomefel. There, I've said it. And I do this every time. Some of you object to it because you say I've done it before. You're quite right, but we get new viewers all the time who won't know this, and therefore we do try and make our videos accessible to everybody, especially those who are new visitors. So let me explain why this blue ring is equal to the same digits you get in the 2x2s in the corner. Now, another way to do this is to look at, do I want to use a blank grid to do this? I will just use a blank grid actually. I'll just duplicate the tab and then restart it. Okay, so what we're going to do is we're going to highlight the whole of row 3 and the whole of row 7. And I'm going to highlight those in blue. And I'm also going to highlight the whole of box 4 and the whole of box 6, and I'm going to highlight those in blue as well. Now hopefully it's very clear to everybody that what I've just highlighted is 4 sets of the digits 1 to 9, i.e. if I finish this puzzle completely correctly and we analyse the contents of the blue cells I've just highlighted, we would find we've got 4 sets of the digits 1 to 9, because row 3 must be a complete set of the digits 1 to 9, as must row 7, as must box 4, as must box 6. So what I want to imagine is that I write all those digits down on Scrabble tiles, 1 on each Scrabble tile, and I put them in a blue bag in this hand. So I have got 36 digits in this hand in a blue sack, equal to these blue cells, or the digits that appear in these blue cells. Now I'm going to create a different 4 sets of the digits 1 to 9, and I'm going to put those in an orange sack. So I'm going to take column 1, column 2, column 8 and column 9, like that. So this column, that's going to be a complete set of the digits 1 to 9. So is this column, and this column. So I'm going to write all these digits down on a new set of 36 Scrabble tiles. I'm going to write each digit down, 1 on each Scrabble tile. I'm going to put them in a bag here. So in this bag, I've got 4 sets of the digits 1 to 9, and in this bag, I've got 4 sets of the digits 1 to 9. They contain the same thing because because hopefully you can see that we've got 4 complete sets here, and a different 4 complete sets in orange, but because of the rules of Sudoku, the things must be the same, because a complete column of the Sudoku obviously contains identical digits to a complete row of the Sudoku. Now I want to look at this digit. Let's imagine that digit is a 3 in the finished puzzle. Now what would happen, so at the moment my sacks contain the identical Scrabble tiles. If I was to take a 3 out of my blue set of Scrabble tiles and take a 3 out of my orange set of Scrabble tiles, because there must be a 3 in blue and a 3 in orange, because this 3 is obviously, I would have put that 3 in this one and I would have put that 3 in that one. If I take it out of both sacks, then clearly the sacks still contain the same thing, because they contain the same thing at the start, and I've taken the same thing out of both sacks. So I can take this 3 out, and I can do the same for any cell in the puzzle that has both colours in it. I can just take these tiles out of both sacks. And when I've finished doing that, I know that the bags still contain the same thing. And look at that, I've proved it. I've got a blue ring here that must have the same digits in it as the orange 2x2s in the corner. QED. Isn't that beautiful? Amazing. Amazing. So Phistomefel discovered that. Phistomefel, whose puzzle I'm going to be attempting tomorrow. I don't want to think about Phistomefel. Anyway, so having proved that, we now know, because we know that these 2x2s must be the same digits as in the ring, and because we know that there's a 7 and a 5 in the 2x2s, there must be a 7 and a 5 in the ring. We know that the 7 and the 5 must be flanked by 1s, and therefore you could never put the 7 here, because flanking it with 1s would break the rules of Sudoku. So you're going to have to put 7s and 5s in these cells. So that's one thing we know. Well, it's not. That's actually that pencil marking is unhelpful. There's 1 7 and 1 5 in these cells. I'll just highlight the corners so we remember that. But we do know that there must be 4 1s in the blue ring, and therefore this square here must be a 1 in order to allow that to be true, which is actually surprisingly unhelpful. But we know there's a 5 in the ring. There's a 5 in an orange square, and it's not in those 2 squares. So there must be a 5 in one of those 2 cells, and it must be flanked by 1s in each. So there's definitely either 2 1s here or 2 1s here. Oh, right, okay, so you can't, now the 7s can't go into these 2 squares, look. I mean, the 7 could never go here, but if you do try and put a 7 here, because you have to flank that by 2 1s, it's going to clash with the 2 1s that have to flank the 5. So the 7 must be, does the 7 have to be, yes, it has to be opposite. Yeah, okay, so whichever one of these is 5, you have to put the 7 in the opposite corner and flank it with 2, whoopsie. And flank it with 2 1s. So let's put the 7s there, and there's going to be 1s in one of these arrangements. Alright, that's beautiful. That's absolutely beautiful, because now I'm going to come back to the middle box again and ask where 1 goes in the middle box. Because I know there is a 7 in one of these 2 cells, I know that there is a 1 in one of those 2 cells. Therefore, there is no 1 in an 11 cage. Well, there's no 1 in that 11 domino either, and there's no 1 in this domino because 1 is not equal to 8 or 9, another knowledge bomb we share with you on Cracking the Cryptic. So this must be a 1-5 pair. Now, because of the 11 cage here, you can't put 2 or 3 in this 11 cage because you'd need to accompany them with 8 and 9. So there must be a 2 and a 3 in the 3 cell 11 cage along with a 6 to make 11, which means those squares are 4 and 7. And that is very nice because that means this is an 8. We've already looked at 8s. They bounce back over here and give us a 2-8 pair. So 2, we can place 2, I think, in this box now by Sudoku of all things. That square there is a 2. And that's in the blue ring, which means multiples of factors, which is not helpful actually. 2 has probably the most options apart from 1 as digits that can accompany it. Okay. 8. Got it. Right, 8. Where does 8 go in box 4? Boom, 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 boom. There are 4 8s looking at box 4. Whenever you get 4 8s, or 4 of 1 digit, looking at a box of a Sudoku, you can always write that digit into that box. So the 8 goes here, and that's very exciting to me. These are the things that excite me. I'm sorry about that, but look now, this can't be 7 anymore, because we know 7 must be flanked by double 1 in the blue ring, not 8 and 1. 7 and 8 are not multiples or factors of each other. So the 7 moves from this corner to this corner, where it gets double 1'd. And now you can't put 5 here because you can't flank it with double 1 because of the double 1's up there. So that means that the 1 must, or the 5 must go here along with double 1. How many 1's have we put in the puzzle? The answer is all of them once I do the middle box. This is very nice indeed, isn't it? It's very, very cute. A very unusual way to think about or to use the Phistomefel ring to sort of create this mathematical relationship that creates problems or restrictions on prime numbers, especially the numbers 5 and 7. Like it a lot. This is an 8, so this is a 9. Okay, so how do we make this? Can we keep going relatively efficiently? That would be very nice. 2, 3 and 6 here, so that's got to be a 9 by Sudoku. That's got to be a 6. So that's got to be a 4. This 9 here means this has got to be a 3, so we're still going. So what are those two squares? They're a 5, 7 pair. Okay. That's 5s and 7s in the green ring. I've not done anything in the green ring. Oh yeah, these ones have to be close together. They can never be more than 4 apart. There's got to be a 7 in this domino. That's not that helpful, is it? Can I get this? No. Oh, I'm stuck. Oh dear. What are those squares? 4, 6 and 8. Okay, don't know how to do that. We might have to use the Phistomefel ring again here. Let's just see if we get anything from Sudoku. 2, 4 and 6 down here. And that's interesting, isn't it? All those digits are close to each other, or close enough that we can't even deduce anything with this sort of anti-whispers rule going around the green ring. 9 is to be in one of those two cells. That 9 could be a bit restrictive in terms of the green ring, because obviously that means that its neighbour has to be a 5, 6, 7 or 8. Okay, so what is going to be the easy way to make progress here? Come on, Simon. Maybe it's the central row. 3, 4 and 7. Let's put the options in and see what we can see. I can see that can't be a 4. Hang on, the blue ring was multiple. Yes, here we go. The blue ring is multiples or factors. So 8 needs to go with an even digit or a 1. Well, it can't go with 1. There's a 1 here, so that must be a 4. Which means that's a 3 and that's a 7. Which means that's a 5 and that's a 7. And now we know this digit, that's got to be a 3. And now we know, what have we got over here? A 5 and a 6. But, yeah, we've got a 2 here, so this has got to be even, because 2 and 5 aren't in a factorial or factor or multiple relationship with each other, so that becomes 5. 6 now must go with, well, it can't go with a multiple of itself, because that would be 12 or something like that, and it can't go with 1 or 2, so that's got to be a 3. That's not a 6 anymore. So this square is a 4, 5 or 8. And this square has to be, well, it's either got to be a multiple of 3, which would include 6, obviously, or it's got to be a 1. Hang on, a 3 here, that's just got to go with 6, hasn't it? Oh no, it could be 9. Oh, it can't be 9 because there's a 9 here. Right, this is a 6. So that's not a 6 anymore. Oh, in fact, that's not a 3 either, so that means we've got a 3, 6 pair there. We need 4s, 5s and 7s into column 6. Not sure if we can do anything with that. We probably can, I'm just not seeing it. What about that digit, though? That's got to be a 2. It can't be a multiple of 6, and it can't be a 1 or a 3, so that's a 2, which means that's not a 2. 2 is not in that square anymore, so this is, and this 6 is giving us a 4 here. There we go. So now we've got a 2, 6 there. Although again, I don't think I can use the whisper thing. So, can you put a 2 here? Or maybe this digit actually, because this has got to be in a relationship with 8. It's got to be a 2. It can't be a 1 or a 4, so that's a 2 there. Now this square can't be a 1, so it must be a multiple of 2. So this is a 4, well, it's a 4 or an 8 bobbins. Oh, but then this square must also be a 4 or an 8, because it's got to be even, given it can't be a 1. So 4 is not there. This square here is a naked single now. That's got to be a 6. That gives us a 4-8 pair here. 4, 8 and 9 to complete column 9 of the grid. Yeah. Yes, okay. So we know there's a 9 in this domino, so there can't be a 4 in this domino because they're 5 apart. So there's no 4 down here, and that means the 4 goes up there, the 8 goes here, this square here is... oh, that's annoying. I just get left with a 4-5 pair apparently. Oh, no, I was thinking... I've got an 8 here. Okay, so 9, 8... Oh no, it still doesn't work. I was hoping the 9 would attach to the 4 or the 5, which would have resolved it in the green ring, but it doesn't. The 8 does. Oh dear. Okay, so we're going to have to... We've done the ring all but, apart from this 4-8 pair. So how do we tidy up the puzzle now? There must be a way. Oh, we can get that digit by Sudoku. That's a 9. So this square is a 6. It's the only thing it can be because it can't be a 2. We need to put a 2 in this column. So that's a 2, that's a 6. That's no longer a 2, so this is a 2. This 6 is doing the 7 at the top. That's a 6, that's a 6, that's a 3. Here we go. 3, 8, 8, 4, 4, 7. And that must be a 3. Oh, okay, so we're still not quite done, I don't think. We've got 5, 7s and 9s to go in. So that can't be 5, this can't be 7, and that can't be 9. And we still haven't quite finished. So this square is a 7 or an... Oh, I don't believe it. That seems to be a 7 or a 9, which can obviously go next to 6 in the green ring. What about this one? That's a 5 or a 9. Okay. This is confusing me now. So we know one of these is a 9. Oh, I know how we do it. We do it from the top. I was thinking I can't resolve this. But if I look at the top, this is really beautiful. 3 can't go next to 9, so that must be 7. That must go with 5. That gets us a 9 here, a 5 here now. This square's a 9. This 5 is resolving a 4 here, a 5 here, a 4 here, and a 7 here. And let's just check this ring. Yeah, 9 and 5 are 4 apart. I'm just going to have a quick spin round it. I think it's all right, isn't it? It looks like it's correct. 9 and 5 there. That's as close as it gets. And this one needs to be in multiple or factor relationships. So let's have a quick squiz at this and see if we can see anything wrong with it. Nah, this looks good. This looks good. Yes. Beautiful. Steve 360. I really enjoyed that. That is incredibly elegant and a very unusual way of using the Phistomefel ring. So I hope you enjoyed it. Let me know in the comments. Let me know if you're going to be joining me tomorrow night, 9 o'clock UK time. As I say, it could be a long one. And we'll be back later with another edition of Cracking the Cryptic.